Hello viewers, Wagadaru now taking you through the tutorial for A-level applied mathematics, and this video I'm going to go through the topic of descriptive statistics that consists of grouped and ungrouped data. So this video is suitable for students in both Senior 5 and Senior 6 offering principal mathematics as part of their combination. So before we start, let's first look at the course outline and also our progress so far. So math paper 2 or applied mathematics is divided into 3 parts. The first part is mechanics, but mechanics is further divided into 3 parts. So this is the part of mechanics where one question comes in section A and one section B, and these are the topics. Then the other part of mechanics is dynamics, where one comes in section A, one section B, and these are the topics. The third part of mechanics is called statics, where one comes in section A and one section B, and these are the topics. Then the second part of applied mathematics is statistics and probability, where 3 come in section A and 3 in section B, and these are the topics. Then the last part is numerical methods, where 2 come in section A and 2 in section B, and these are the topics. So what is ticked has been covered. For example, numerical methods has been entirely covered. Then statics, some have been covered, others have not yet, like the center of gravity has not yet been covered. Then statistics and probability, these ones were covered fully. Then the ones with half ticks means that their videos will be remade. So the video for scatter graphs and correlation will be remade, the one of price indices will be remade, and the one of probability theory. Then this part we are left with resultant and relative velocity, which will also be remade. And here we are left with these videos. So what is ticked, what is given with a full tick, means the video is available. Then what has a half tick, it means it is available but it is going to be remade. And what is not yet ticked means it is still pending. So in this video I'm going to remake the video or the topic of descriptive statistics. And also, as a reminder, at the end of the video there will be end screen. So if you want a video for numerical methods, you just double click here. The video of mechanics, you just double click here, and the one of probability and statistics, you just double click here at the end of the video. So now we shall start on our topic for today, descriptive statistics. So first of all, statistics refers to collection, interpretation, presentation, and analysis of data. Therefore, descriptive statistics comprises of those methods concerned with collecting and describing a set of data so as to obtain meaningful information. So those methods are the parameters. So data is divided into 2. There is grouped data and ungrouped data. So we shall look at both in this video. So let's start with ungrouped data. So the parameters for ungrouped data include the following. 1, we have what we call mean or average. Then we also have variance. Then we have standard deviation. So mean is the same mean we covered in O-level, but variance, it is new. Standard deviation is new. Mode is also the same mode you covered in O-level. Median is also the same median. So we shall look at all these parameters and ungrouped data. Let's start with mean. So what we are going to do, we are going to first list down all the formulas for all the parameters. After that we shall do worked examples. So let's start with mean. So the formula mean is the sum of data values divided by the number of values in the data, for example, and it's denoted by a symbol x bar. So when you see a bar, just know that it is that expression is for mean, and the formula is this summation x. So this x bar means mean of x, and mean of x means that you get the sum of all the data values of x, which is this denoted by this summation sign, over the total number of data values. We shall see how this formula is used. Then next is variance. Variance is the variance of x is given by the formula. So there are 2 formulae for variance. You can either use this or you use this. So you're already seeing that this x bar means mean of x, and this one is the data value of x, and is the number of data values. Or you can also get your variance using this formula, which is summation of x squared over n minus, in brackets, summation of x over n everything raised to the power 2. So you must be keen with the brackets being used. Now the good thing is that these formulae are available in your mathematical logbook. For example, the formula for variance, it is here, and this is the very formula we have seen here. If you compare it with this, the only difference is the symbols used. For example, for them, instead of using x bar for mean, they used small m. I think you can see it here, small m to mean mean. Then also, instead of using small n for the number of total number of data values, they used capital N. But it's all okay. It is up to you to choose which symbol is easier for you to memorize. So any of the two is okay. But since in your O level you are used to expressing mean in terms of x bar, that is why I choose to maintain the x bar and also to maintain this small n, so that you don't get confused along the way. So let's look at this proof. Now the proof that this variance, the proof of the two expressions for variance. So we shall start with the left hand side, which is this. The next, we are going to open this bracket. So when I open this bracket, I'll come up with this. Then next, remember this summation sign is for all these ones inside. So what I'm going to do, I'm going to put the summation sign on each to come up with this. Then also you realize that on this second part, on this part, 2 and x bar are outside the summation sign. Why? It is because this is a constant and also mean is a constant, but this one keeps on changing, as we shall see in the worked examples. So that is why it is only one under the summation sign. Then at this step there is something funny. Here it was summation of x bar squared, and here it is n x bar squared. Why? Because this summation means we are going to keep on adding this mean how many times? N times, because those are the total number of data values. So you say x bar squared plus x bar squared plus x bar squared until you get the n times. So that means that this one, this summation of adding all of them, it is the same as n times this value. Just like we are saying 2 plus 2 plus 2 5 times, it's the same as 2 times 2 times 5. If I say 2 plus 2 plus 2 5 times, it means that it's the same as 2 times 5. So even here it's the same thing. I'm saying x bar squared plus x bar squared plus x bar squared n times, therefore it will be x bar squared times n. Okay, so now that that is known, let's proceed to the next line. Now in this next line, what we are going to do, we shall remember that this x bar means mean. So I'm going to substitute with a symbol expression for mean. Remember, mean is summation of x over n. Do the same here, summation of x over n, but be mindful of the brackets. Now from there, this one, remember this squared works on both the numerator and denominator. So this is summation of x everything squared over n squared. But remember there's also another n here, meaning that one n here will cancel this n to remain with just one n. That is why here it is no longer n squared, it is just n. Then for this part, this times this, it is the same as summation of x squared, but be mindful of the brackets. So now here, remember these ones, this one is the same as this one, so it is as if we are saying negative 2 plus 1, which is negative 1. That's why you see a negative 1 of the whole of this. Now next is to split the numerator. So this one is same as this over n, which is here, then also this over n, which is this. So now I think we realize that we have n squared in the denominator because there is this n and also this n to give you n squared. Therefore, you can rearrange to get this expression as before. So that means that for variance, you can either use this formula or this formula. Now, which one is preferred? This one is the most preferred formula to use. This one is used in very rare circumstances, as we shall see in the worked examples. So that was variance. Now we shall go to standard deviation. So standard deviation of a given set of data is the positive square root of the variance. Not this word positive square root. Remember, square root of any value has plus or minus. So now here we take the positive square root, and it's given by the formula. Remember, this was the formula for variance. So when you put square root, it becomes standard deviation. Similarly, this was the formula for variance, and when you put square root, it becomes standard deviation. Then now we shall go to formula 4 or parameter number 4, which is mode. So mode of a given set of data is the data values that appears most frequently in the given set of data, or the value with the highest frequency. Then median of a given set of data is the estimated value falling midway when the data values are arranged in either descending or ascending order. So to obtain the median, we have to first arrange the data values in either ascending or descending order. After that, we shall say that if the number of data values is odd, the median will be the middle value. That is when it's odd, as we shall see in the worked examples. But if the number of data values is even, the median will be the average of the two middle values after arranging in ascending or descending order. So that knowledge, let's go through these questions. So question 1 says that time in seconds for phone calls made by 12 customers at the public telephone booth were recorded as follows. So these are the seconds taken by each. Then say find Roman 1 the median time, Roman 2 the mean time, and Roman 3 the standard deviation. So we shall start with the Roman 1. So for the median, remember we said we arrange in ascending order. So this is an ascending order or descending. So in this case we have arranged in ascending order. After that we keep cancelling at ends. So 1, 1 at both ends. Then 2, 2. Then 3, 3. Then 4, 4. And 5, 5. Now I'm left with two values in the middle. So what I'll do, to get the median, I'll have to divide to get the average of those two values. So this plus this over 2 gives me 107.5, and that would be the median time they wanted. Then Roman 2 they wanted the mean time. Remember, mean is summation of x over n. So let me first get the summation of x. I'll have to add all the values, and when I add, I'll come up with 1298 using a calculator. After getting that, I'll come and say that mean time is equal to summation of x over n. Therefore 1298 divided by 12 gives you this to 4 decimal places as your mean time. Then Roman 3 they want standard deviation. So remember, standard deviation, we need the value of summation of x squared. So let's first get summation of x squared first. Now some students confuse this summation of x squared with this. There's a difference between when there is a bracket like this and this just summation of x squared. Now this one means we first get summation of x as we did it for under the part of mean, then you square the outcome. So here we would have squared the 1298, but because here there is no bracket, it implies that this one is different from this. Therefore, what we have to do, get each value of x and square it independently. When you do that, after that you add all the values, and when you use the calculator to add all the values, you'll come up with 141,958 as the value of summation x squared. So always remember that. Most students get confused along the way. So now that I've got that, I'll come and get the value for standard deviation. Remember I told you there are two formulae for standard deviation, but like I told you, this one is the one which is easier to apply. So the second one is applied under rare cases, as we shall see still in this video. So in this case, I'll use this formula which is easier and substitute for this. Then n, I know it is 12. We already told in the question. Then this summation of x, we got it under the part of mean, it was this, and the n is 12. So we must be keen with the brackets. So when I use the calculator, the whole of this inside the square root will be this for decimal places. And when I get the square root, I'll come up with this as the standard deviation. That was question 1. Now we shall go to question 2. Question 2 says the mean of the numbers these numbers 3, 6, 7, 8 and 14 is 8. Find the standard deviation of the set of numbers. So first of all, we shall remember that the mean is given by sum of all the data values divided by the total number of data values. So these are 5 because 1, 2, 3, 4, 5. There are 5 data values, that's why you put 5. And they told us that the mean is 8. So what we are going to do, we shall cross multiply to come up with this, then make a the subject to come up with the value of a as 10. Now they talked about standard deviation, and like I told you, standard deviation requires the value of summation of x squared. Summation of x squared means that each value is squared independently. Now here where there is a, we shall put the value of a, which is 10. After that, then you'll use the calculator and you'll come up with this value, 390. Now that I've got that, I can go back to my formula for standard deviation and substitute. Now here we're using x bar. Remember we said x bar is the same as summation of x over n. So instead of writing summation of x over n, I can simply write x bar, as long as this mean is an exact value or a whole number without recurring decimals. In question 1 it had recurring decimals, that's why you couldn't use it. We had to divide again. So when I substitute, I'll come up with this, then use a calculator, I'll come up with this as the standard deviation. Then question 3 says, for a set of 9 numbers, summation of x minus x bar squared, x bar everything squared is equal to 60, and summation of x squared is equal to 285. Find the mean of the numbers. So it is in this case where you can use this formula for variance, because in the question they are giving you the value of summation of x minus x bar everything squared. So if this value is given in a question, it implies that you can use this formula. If it is not, then the only option is this. So since these two formulae are for variance, we shall equate the two and then we substitute. When I substitute, I remain with x bar squared as the only unknown. So I'll come and make it the subject, then put square root on both sides to get x bar as 5, and that's what they wanted because x bar denotes mean. Then question 4 says the numbers a, b, 8, 5 and 7 have a mean of 6 and variance of 2. Find the values of a and b if a is greater than b. So first of all, the mean was 6, and mean is summation of x over n. So what I'm going to do, I'm going to get summation of x by adding all these values. Then n is the total number 1, 2, 3, 4, 5. That is why you put here 5. Then when I cross multiply, I'll come up with this. And simplify, take this one this side, I'll come up with this, because this is 30 minus 20 to give you 10. And when I make b the subject, b will be 10 minus a. That is equation 1. That is for mean. What about for variance? Variance is given by this formula. Like I said, when mean is a whole number, you can easily just write x bar here in the formula for variance. So I'm going to substitute. So summation of x squared is this. Each value is squared independently. That is what you must remember. Then n is the total number of data values, which is 5. And x bar was 6, so you have to square it, and this 2 is maintained. So when I substitute for b, I'll come up with this. Cross multiply, I'll come up with that. Collect like terms, I'll come up with that. Reduce, divide throughout by 2 to come up with this. So this is a quadratic. I have to solve the quadratic using either factorization or bulldozer method. So let me use the bulldozer method, or what we call the quadratic formula. B is negative 10, so negative b is 10, and b is negative 10 there. Then a is 1, and c is 24. So when I use that, I'll come up with two values of a. A will be 4, or a can be 6. So I've got two values of a, so we have to also get their corresponding values of b. But remember, a is greater than b. We shall use that condition to eliminate one of the values. So for a equal to 4, b will be 10 minus 4, which is 6. What about for a equal to 6? For a equal to 6, b will be 10 minus 6, which is 4. Then from there, remember that a must be greater than b. So that means that a cannot be 4, because when a is 4, b is 6. Therefore, a is 6 and b is 4. Then we shall go to question 5, which says the set of digits consists of m zeros and n ones. Find the mean of this set and show that the standard deviation is given by this expression. So remember we said m0, so it means that m0 plus 0 plus 0 m times, that is why we get m times 0. Then 1 plus 1 plus 1 n times, that's why we put here n times 1. So when we add the 2, I'll come up with n as our summation of x. What about summation of x bar? So it is m times 0 squared plus n times 1 squared, which gives you also n. Now that I've got that, I can go back, I can go and get my mean. So mean, which is x bar, is summation of x over the total number of data values. So total number will be m plus n, because it has m zeros and n ones. That's why you see here m plus n. And when I substitute for summation of x, I'll come up with n over m plus n. That was mean. What about variance? So variance, we are going to first get variance, because we already know that standard deviation is square root of variance. So after getting variance, we can just put a square root, and that will be our standard deviation. So variance is the same as summation of x squared over the total number of data values, which is m plus n in this case, minus the mean, which is already here. So I'll come and substitute. Summation of x squared is n, summation of x is n. The LCM is the same. It's not the same here, it is m plus n squared, and so yes, m plus n. Therefore, the LCM will be m plus n squared. Now m plus n squared divided by this, 1 m plus n cancels, remaining with m plus n multiplied by n to come up with this part. Then this one divided by this, it is 1, so remain with only n squared, and the minus is maintained. Then from there, I open this bracket to come up with this, nm plus n squared minus n squared. Now this and this can cancel, remain with NM. Now that is variance. Therefore standard deviation will be got by putting the square root. So square root of variance is this, and when you simplify, this square can cancel this square root to remain with no square root in the denominator, but for the numerator the square root will remain, and that's what they wanted you to prove. Now we shall go to question 6, which says Kate noted the weights X grams of 30 chocolate buns. Her results are summarized by this: summation of x minus k equal to 315, and summation of x minus k everything squared equal to 4022, where k is a constant. The mean weight of the buns is 50.5 grams. Find Roman 1 the value of k, and Roman 2 the standard deviation of x. So yeah, start with Roman 1. So mean is 50.5, so mean is summation of x over n, and it was given as 50.5. So what I'm going to do, I'll cross multiply to come up with summation of x being equal to this, but the value of n was given as 30, so I'll come and substitute for n and be able to get the value of summation of x. Then we're also given this summation is equal to 315. So when the summation work is put on each of these ones, you come up with summation of x minus summation of k equal to 315. Then this one we have already got it as this. Now this one there is 30. Why? Because the summation of k means, remember k is a constant, so you're multiplying, you are saying k plus k plus k how many times? 30 times. So k plus k plus k 30 times, the same as 30 times k. This one is maintained. Then my aim is to make k the subject, so I'll take this one this side and this one this side to come up with this. And when I make k the subject, k will be equal to 40. That was Roman 1. Then Roman 2. Roman 2, they want the standard deviation of x. So we are given that this is equal to this. So what I'm going to do, I'm going to substitute for k, which is that, then open this bracket, expand this bracket to give you this. Then from there I'll put summation on each. So this 80 is outside because 80 is a constant. Also here it is summation of 1600. But remember this one is also a constant, so it is like we're saying 1600 plus 1600 plus 1600 30 times, so it's the same as 1600 times 30. Then now use the calculator and simplify. I'll come up with this being, take all these ones this side, you'll come up with this 77222. Therefore variance is equal to this formula. I think you remember this formula. So the good thing, I've got summation of x squared, and also I have summation of x, or the mean, which is this, and also I have the value of n, which was 30 based on the question. So that gives me this as my variance. Now we shall go to parameters for frequency distribution for ungrouped data. Now this involves collecting like quantities and writing down how many of each type they are. So the number of like quantities is called the frequency. So in this part of ungrouped data, we shall be using this frequency frequently. So the table showing like quantities together with their frequencies is what we call the frequency table, or the frequency distribution. And the parameters for ungrouped data with frequency distribution, they are somehow the same as those ones for just ungrouped data, but here we add on some others. We add on the quartiles, we add on the deciles, and we also add on the percentiles. then these ones are the same as before, but the formulas will somehow change. So we are going to first list down all the formulae, and after that we shall go to the worked examples. And these formulae are also available in your mathematical logbook. For example, if I want the formula for mean is here. Here we have summation of fx over summation of f, which is here summation of fx over summation of f. The only difference is that for them, the symbol for mean is m, and for us our symbol for mean is x bar, but the rest is the same. So I think by now you know x is the data value and f is the frequency. Then for variance, still the formula is available here, the formula for variance, which is this one. The only difference is that for them they have started, for us we started with we said fx squared, for them they're saying x squared f. Why? Because some students, let's see here, some students when they look at this, they may think that this square is on both f times x, which is not the case. So this square is only on x. If you want a square to be on more than one part, we have to use brackets. Just as you see here, this bracket means that this square is on both the numerator and the denominator. So you must be keen with the brackets. Even here, this square means it's on both, is on the whole of this expression, which is x minus x bar. Standard deviation, you already know the square root of variance, so just get the square root of this to give you that, and square root of this to give you that. So I think we realize that what is changing is that now here instead of writing n, we are writing summation of f to mean total frequency. Then the other parameter is median. So median, now median is a little different from the one you have covered for just ungrouped data. When it is ungrouped and it has frequency distribution, the way we get median is a little different. So how do we do it? This is the value of x, which corresponds to a value slightly greater than or equal to a half n, half capital N, in the cumulative frequency column. So this CF means cumulative frequency, and this capital N means total frequency. So we shall see how to get median under the worked examples. But for now, what we are doing, we are first setting all the formulae. So now median, quartiles, percentiles, and deciles, they almost have the same formulae. The only difference is the position. For example, for the median, it was slightly greater than or equal to a half n. For lower quartile, it will be slightly greater than or equal to a quarter n. And for upper quartile, it will be slightly greater than or equal to 3/4n. Now in quartiles, there are some special words they use. They can use the word interquartile range. Now that one means you subtract the lower quartile from the upper quartile. They can also use the word semi-interquartile range. So that means that you get the interquartile range and you divide by 2. So Q3 is the value for upper quartile, and Q1 is the value for lower quartile. So now we shall go to decile. So decile it means over 10 or a tenth. So if they say kth decile, they usually give you the value. They can say fourth decile. So fourth decile means that the position is 4/10. If it is ninth decile, the position is 9/10. So in this case, let's use a general value k. So kth decile means that it is k/10 as the position, but the formula still remains as the one for median and quartiles. Now there are some cases where they'll just say decile range without specifying the value of k. So in that case, it means that you are going to get D9 minus D1. Now D9 means ninth decile, and D1 means the first decile. Then percentile means out of 100. So if it is kth percentile, it means the position will be k over 100. Now you must note that this is just the position. The value of the percentile is this, pk. Similarly, if they just say percentile range, it means that you get P99 minus P1, and that would be the percentile range. So what we are going to do, we are going to summarize all the formulas you have seen in this question 1. So I think realize that this question contains all the parameters. It contains mean, variance, standard deviation, median, semi-interquartile range, deciles, and percentiles. So we are going to see how you can answer questions on parameters for ungrouped data with frequency distribution. So this question says the marks obtained in a test by applicants securing to become head teachers are recorded in the table below. So these are the marks, and these are the number of applicants. So they want you to find all these parameters, and that's what we are going to do. So what we are going to first do, we are going to tabulate the necessary values. So what the first column will be for x. Now x are the data values. If you look at this, so these marks will be the values of x. The number of applicants will be the frequency. So we are going to first put the values of x as they are. The next will be the frequency, and for frequency we put there these very values, which is for number of applicants. So let's do that. Okay, now because they ask for mean, we need to get the we need to also generate the values of fx. So fx means you will multiply these values of this column with values of this column. So when I multiply this with this, I'll come up with the value here, which is 10. This with this, I'll come up with this value, which is 20. This with this, I'll come up with this value, which is 15. This with this, I'll come up with 60. This with this, I'll come up with 50. This with this, I'll come up with 60. This with this, I'll come up with 105. This with this, I'll come up with 200. So after that, I also need their total, so I'll add all these values and come up with 520. Now this is the column which will help us to get the mean, but they also asked for variance, so we need the column for fx squared. Now fx squared means x squared, this squared times this, to give you what to put here. So 1 squared times this gives me 10. 2 squared times this gives you 40. 3 squared times this gives you 45. 4 squared times this gives you 240. 5 squared times 5 times 10 gives you 250. 6 squared times 10 gives you 360. 7 squared times 15 gives you 735. 8 squared times 25 gives you 1600. Now also I have to add all these values, and when I add all of them, I'll come up with 3280. Then I also need the column for CF, or cumulative frequency. Now that column will let me get the quartiles, deciles, percentiles, and median, as we already saw in the formula. So cumulative frequency, how is it generated? You keep on adding frequencies. For example, I'll first start with this to put it here. Then this times this plus this gives you what to put here. Then 20 plus this gives you what to put here. Then this plus this gives you what to put here. Then this times this, plus this gives you what to put here. and this plus this gives you what to put here, this plus this gives you what to put here, this plus this gives you what to put here. So I think you realize that this last value in CF is the same as this value of the total frequency. Okay, so now that is the table we need. Next is to answer the questions. We shall start with Roman 1, where they wanted the mean mark. So the first thing to do is to remember the formula for mean. So mean is summation of fx over summation of f. Now summation of fx, we already saw it in this part. If you look at this, summation of fx is this 520 and summation of f is this 100. So I'll come here and substitute 520 over 100 to give me 5.2 as the mean mark they wanted. Then Roman 2, they wanted variance. Now variance is summation of fx squared over summation of f minus mean squared. So summation of fx, we already got it here. If you look at your table, summation of fx is this 328, so that's what you are going to write here. 328 over 100 minus mean, so this is the formula for mean. This mean here is what you put here and you square it to come up with this value as your variance. Then next they also ask for standard deviation. You already know standard deviation is square root of variance, so square root of this will give me 2.4. Then they also ask for median. So now median you have to first get the median position. Remember, median we said is the value of x which corresponds to a value slightly greater than or equal to a half n in the cumulative frequency column. So this a half n is what we call the median position. So n is the total frequency. It was 100, so 100 times a half gives you 50. Now some students, what they do after getting this 50, they think that will be the median. So in order not to confuse it, that is why we add there this th to help you remember that this is not the median, it is just the median position. Now it's from this median position that we are able to get the median mark they wanted. Now how did we get this 5? Let's go back to the table and see how we got it. So remember we said we go to the cumulative frequency column and look for a value slightly greater than or equal to 50. Now the good thing, 50 is already in our cumulative frequency column. So what we do, we shall look for the corresponding value of x. So when the corresponding value of x will be 5. So that is why when we come here we said that median mark is 5. So now we shall go to Roman 5. Now Roman 5, they ask for semi-interquartile range. So the first thing to do is to get the lower quartile and the upper quartile. Now for the lower quartile, we have to first get the position. So the lower quartile position is a quarter n. I think remember that in the formula. So a quarter n is 100, which is the total frequency. So a quarter times 100 gives you 25. Now we are putting this th here because some students, after getting this 25, they think this will be the quartile they want, but this is not the quartile they want. The one they want is this 3. So here we put th so that students realize that it is not the very end, it is just a position, but you have to go ahead and get the lower quartile. Now how did we get this 3? We shall go back to our table and look for, let's first remove this. So we shall look for a value slightly greater than or equal to 25. Now the good thing, we have 25 exactly here, so and it corresponds to 3 in the column of x. Therefore we shall come and conclude that the lower quartile is 3. What about the upper quartile? We will still have to get the upper quartile position, which is 3 over 4n, and it gives you 75. Now 75 is just the position, but the upper quarter where they want is 7. So how did they get 7? We shall go back to our table. First remove this and locate for a value slightly greater than or equal to 75, which is 75 is exactly here, so it corresponds to 7. Therefore 7 will be your upper quartile. Now that I've got Q3 and Q1, I can come and substitute in the formula for semi-interquartile range. So semi-interquartile range is Q3 minus Q1 over 2, and gives you 2 as the value they want. Then Roman 6, they wanted decile range. Now decile range means D9 minus D1. So for you to get D1, you have to first get the D1 position. And decile, remember, decile means out of 10. Therefore D1 is 1 over 10 times n, and n is 100, so we'll come up with 10. Now, like I told you, we put this to help students remember that this is not the final answer they want. What they want is this one, but the question is, how do they get it? We have to first get this position, and after that position we shall go back to our table. And locate the position, a value slightly greater than or equal to 10. The good thing, we have 10 exactly here, so 1 will be our first decile. Then next we also have to get D9 or 9th decile. So D9 position is 9 over 10 times 100, which gives you 90. Now 90, we shall go back to our table and locate a value greater than or equal to 90. Now if you look at this, for example, D9, 90 is here because this is 75, which is less, but we want a value which is slightly greater than or equal to. So from 75 we go to 100, meaning that 90 is enclosed in this 100. Therefore the corresponding value of x is 8, meaning that our D9 is 8. Now that I've got D9 and D1, I can get my decile range by subtracting the 2 to come up with 7, which they want. Then Roman 7, they wanted third decile. Third decile, the position is 3 over 10 times n. So 3 over 10 of n is 30th. So 30, we shall go back in our table and look for a value slightly greater than or equal to 30. And that value will be 40, because before 40 we have 25, which is less than 30, meaning that 30 is enclosed in this 40. Therefore x, corresponding value of x is 4, meaning that our D3 is 4. That is why you see here 4 as the answer. So now we shall go to Roman 8, which is percentile range. So percentile range is P99 minus P1. So P1 position is 1 over 100 times n, and that gives you 1. So we shall look for 1 in our, this is the position, so we shall first look for it in our cumulative frequency column. So we shall first remove this and locate our P1. P1 is enclosed in this because before it is 0 or nothing. Therefore the corresponding value of x is 1, meaning that our value of P1 is 1. What about P99? So P99 position is 99. So that we shall come and look for 99 in our cumulative frequency column. And 99 will be enclosed in this because before it is 75, which is smaller than 99. And the corresponding value of x is 8, meaning that P99 is 8. That is why you see 8 here. The next is the percentile range. So percentile range will be P99 minus P1, which gives you 7 as the answer. Then now shall go to Roman 9. So Roman 9, they want 70th percentile or P70. So first of all, you have to get the position. So 70 over 100 times 100 gives you 70. Therefore, we shall look for 70 in our cumulative frequency column. and 70 is enclosed in 75 because before this you have 60, which is smaller than 70, and the corresponding value of x is 7. Therefore the value is 7. That is why you see a P70 as 7. Then Roman 10, they wanted P25 to P30 range. So P25 position will be 25. So after getting the position, you'll go back to your table. First remove this, then I'll look for the P25 position, which is here and corresponds to 3. Therefore P25 is equal to 3, which is here. What about P30? So P30, 30 over 100 times 100 gives you 30. Therefore you'll go back to your table and look for 30 in your cumulative frequency column, and that 30 is enclosed here, which corresponds to 4. Therefore P30 is equal to 4. That's why you see 4 here. Therefore the range will be got by subtracting the 2 to come up with 1 as the required answer. So now shall go to question 2, which says that for a given frequency distribution, summation of f in brackets x minus x bar squared, x bar when x minus x bar squared is x minus x bar is squared is equal to 182.3, and summation of fx squared is 1025, and summation of f is 30. Find summation of fx. So from here I shall remember the expression for the two expressions of variance, and shall first code them, then we substitute. So this one is already given here, so we shall come and substitute it. Then summation of f is here, so we come and substitute. Summation of fx squared is here, so we shall come and substitute. Summation of f is here, come and substitute, and also put it there. So I think you realize that now we only have this as the only unknown. So our aim is to look for a way of making it the subject. So when I take it this side and bring this one the other side, I'll come up with this line. Then use a calculator to simplify this. I'll come up with this 28.09. Then I'll first put square root on both sides to come up with this line. Then cross multiply to come up with this, and then use the calculator to come up with the value they wanted. Then question 3 says a certain piece of data gave the following results. Summation of fx squared is that, summation of fx is that, and standard deviation was calculated as 5. Calculate the summation of f. So we shall come and say that let y be our summation of f, which they want. Therefore we shall come and say that standard deviation is given by this formula. I think by we know it. So you come and substitute standard deviation is there. Then summation of fx squared is 10,000. Summation of fx is 600. Summation of f is what they want, so let it be y. So I think we realize that we have only one unknown, which is y, so we have to simplify. So square both sides to come up with this line. Then multiply followed by the LCM, which is y squared, to come up with this line. Then reduce by dividing followed by 25 to come up with this line. Then put everything on one side to come up with the quadratic. Then use bulldozer method or quadratic formula to come up with the two values of y. That means that summation of f is equal to 360 or 40. Now we shall go to question 4, which says that find the mean and standard deviation of the first n integers. Know this word, first n integers, and you may use this expression. So I think you remember these expressions and series. These are standard series. So they are the ones we are going to use. So variance is equal to summation of, now instead of saying summation of x, now we are using r as the variable. So instead of x we are using r because that is what we are given here. So summation of r from 1 to n over, sorry, summation of r squared from 1 to n over n minus the mean. So this is the mean. Mean has to be squared. After quoting this formula, you are going to substitute. We know this is equal to this, so I'll come on where there is this, I'll put there that. Then also this one, this summation is here, so I'll come and put it there. This 0.5 is catering for this half. You must remember that it is squared. Everything is squared here. This squared, shouldn't forget it. Then from there, you realize that this n and this n can cancel, so that's why you remain with this part alone. Then also here, this n and this n can cancel, that is why you remain with only this part alone in the bracket. Now from here, the LCM will be 12, because here the denominator is 4, here the denominator is 6, therefore LCM will be 12. Now this 12 divided by 6 is 2. 2 times this one gives you this part. Then this 12 divided by 4 is 3, and 3 times the whole of this gives you this part. The next is factorize, because n plus 1 is common, so I'll pull it out, and here I'll remain with 2 and 2n plus 1, which is here. Then this side I'll remain with 3 multiplied by n plus 1, which is here. There's no more square now because it was n plus 1 was factorized out. Then inside this box bracket, I'm going to expand to come up with that. Then I'm going to collect like terms. This and this is n, and this is -1. Therefore, standard deviation will be equal to square root of variance. So square root of this is the variance, which is here, and realize that this numerator is difference of 2 squares, which is that, and that's what they wanted. So far what we have been dealing with has been ungrouped data. Now we are going to deal with grouped data. So grouped data consists of individual values of a variable that have been arranged in order and grouped in, so the one n has to go away, and grouped in small number of classes. Now we have this word classes. So the terminologies used under group data include the following. So there are some terms we need to know. Some of them, or most of them, you cover them in your O-level, but still we have to talk about them. So the one is the class limits. These are the smallest and largest values that can go into any given class. The smallest value in every class is called the lower class limit. So shall be using lower class limit. When I hear me say lower class limit, it means that the smallest value in every class. What about the upper class limit? Upper class limit is the largest value in every class. Okay, that is one term. Another term is called class boundaries. So these are the real class limits of a given class which make the given data continuous. Now continuous means where one stops is where the other starts from. We shall see it when we are doing worked examples. So class boundaries are got by, first of all, getting the difference between the upper class limit of one class and the lower class limit of the next higher class, and then divide the result by 2. Okay, if the value got after dividing by 2 is delta, the symbols we shall call it delta, then lower class boundary will be got by subtracting delta from the corresponding lower class limit, and upper class boundary is got by adding delta to the corresponding upper class limit. We shall see how that is done, but let's first go through all the terms. The next is class interval. Now class interval, it has 3 words. You can either call it class interval or class width or class size, and this is the length of a class, or you can say this is the range of values a class can contain, and is given by the difference between its class boundaries. So this is the formula to get class width. Class width is equal to upper class boundary minus lower class boundary, and this class width is noted by a letter C, so we shall be using small c to denote the class width. In your O-level you denoted it by letter I to mean class interval, but now in this video we shall be using letter C, small c, to denote the class width. Now there's something we need to note is that if the classes are of equal length, their common class width is also given by the difference between any two successive class marks. Now there's this other term now, class marks. We don't know what it means so far. So note that the class widths are not given by the difference between the respective class limits. Now here you must know the difference between class boundaries and class limits. So class widths are got by getting the difference between the class boundaries, not the class width. You should remember that. So we talked about here class mark. What is a class mark? So class marks are the midpoints of classes, and they are obtained from this formula. You can get the average lower class limit plus upper class limit over 2. It also works. Or you can get it from class boundaries by saying lower class boundary plus upper class boundary over 2. Now any of the two is okay. You can get the class mark, and that class mark is usually denoted by a symbol X. So this X in ungrouped data, it was denoting the data value. So in grouped data, X denotes the class mark. Next is frequency distribution. So this is a tabular arrangement of data by classes together with the corresponding class frequencies. So a table consisting of classes and frequency is called the frequency distribution. The next term is class frequency. So this is the number of values or items falling within the given class interval, and class frequency is usually denoted by letter small f. The next is cumulative frequency. So this is simply the total frequency up to a given point, and it is noted by a symbol capital C dot capital F. So there are two ways. You can either note it by CF or denote it by capital F. But the reason why we encourage C dot F is because some students, they fail to distinguish small f from capital F, and if you fail to distinguish the two, then it is disaster. So it is better to denote cumulative frequency with C dot F. This dot has to be seen. If it is not there, it means that you are multiplying capital C with capital F, as we are doing with fx, which is not true. Okay, so now shall we look at the categories of classes. So in O-level, the classes you are given were limited to a specific part, but in A-level there are various categories of classes. So what we are going to do, we are going to first look at those categories and also learn how to get the class mark, cumulative frequency, class boundaries, and class width. But our interest mainly in this part is on getting class boundaries, because the way you use to get class boundaries in O-level is a little different from that of A-level, because here in A-level we have a number of categories of classes. So here we shall have tables. We shall look at a number of tables which are set in A-level. So, and they will give you the class and frequency, so it will be you to get the class mark, cumulative frequency, class boundaries, and class width. So by the end of by the end of all these tables, you must have realized how to get all these parameters. So let's start with table 1, which has equal class widths. So equal class widths, I think realize that here, from here to here, the difference, this minus this is not a class width, but if you look subtract, you will get 4. Even here you get 4, even here you get 4, even here you get 4. So that means that it has equal class width, but you must take note that 4 is not the class width. Why? Because class width are got from the class boundaries. What I'm getting here is to help you realize whether the class width will be equal or unequal. So let's start with the class mark. Class mark, you add this to this and divide by 2 to come up with this. This plus this divide by 2, this plus this divide by 2, and this plus this divide by 2. So that is how they get the class mark. It is average, upper class limit plus lower class limit divided by 2. Then cumulative frequency, we said it is total frequency up to a given point. So up to this point, the frequency, total frequency is 8. Then up this point, the total frequency is this plus this, which is 15. Then up this point, total frequency is this plus this, which is 48. And up this point, total frequency is this plus this, which is 64. So that is how they generate cumulative frequency. Then class boundaries are our major interests. Actually, is our major, because these ones are easy to get. But class boundaries, they have some tricks behind them. So like we said, the first step to get is to get delta, where delta is the difference between the upper class limit of one class and the lower class limit of the next higher class. Know that word, next higher class. So subtract these 2, you come up with this numerator, then divide by 2, you'll come up with delta as 0.5. Now when you get 0.5, that was what you'll subtract from this to get the lower class limit and add to this to get the upper class limit. So when you do that, you shall come up, for this it will be this, for this it is that, for this it will be that, for this it will be that. Okay, then class width, now class width are got from class boundaries. So this minus this gives you 5, this minus this is 5, this minus this is 5, this minus this is 5. So that, because these values are the same throughout, that is why we call it equal class width. Now this table 1 is the only table used to do in O level, but in A level we add on other types of classes. So like in table 2, which has unequal class width, how do we deal with that? So class mark is still the same procedure, add and divide by 2, add and divide by 2, add and divide by 2. Now here it is only one value, so that means that there's nothing to add, so you only write this as it is. Then here add and divide by 2. Cumulative frequency, you do the same, this one here, then add to this to get this, then 8 plus 2 gets 10, 10 plus 6 gives you 16. So that is how they generate CF. Then class boundary, you first get delta. So this minus this divided by 2, you come up with 0.05. So it means that you subtract 0.05 to get the lower class boundaries and add 0.05 to get upper class boundaries. So when I do that, for this it will be this, for this it will be this, for this it will be, now this one we are going to use the same value to get both the upper and lower class boundary. For example, I'll get this minus 0.05 to get the lower class boundary, and also this very value plus 0.05 to get the upper class boundaries. So I'll come up with this. Then this one gives me that. So that is how they get class boundaries for unequal class widths. Then class width, now this minus this gives you that, this minus this gives you this, this minus this gives you that, this minus this gives you that. I think you realize that now the class widths are not equal, so that's where the word unequal class widths come from. Okay, now we shall go to another category of classes where the class limits are the same as class boundaries. Now if you look at the previous one, these two values were different, okay, but now in this case these two values are the same. So when that happens, it implies that the class widths are the same as the class boundaries. The procedure for x is still the same: add and divide by 2, get that, add divide by 2, get that, add divide by 2, get that, add and divide by 2, get that. Then cumulative frequency still, write this one here, then 10 plus 25 gives you this, 35 plus 30 gives you this, 65 plus this gives you that. So that is how they generate cumulative frequency. Now here, these very values here of class limits will be the very values put here in the class boundary. So we shall just write. Now why is it so? Because here it is 0, meaning that you add 0 and subtract 0, so it still remains the same. So we shall just write the very values. Class width now is subtract, okay, that, subtract, subtract, subtract. Okay. Then table 4, classes with inequalities. Okay, so x is still the same procedure. This plus this over 2 gives that, this plus this over 2, this plus this over 2, this plus this over 2. So now for cumulative frequency, you shall get this 2, put it here, then 2 plus 9 gives you this, then 11 plus this gives you that, then this plus this gives you that. So that's how they generate CF. Then class boundaries, as long as there are inequalities, for you to get class boundaries, you just simply eliminate these inequalities, and what is left is what you write here. So let's do that. We shall come up with that, that, and that. So I think we have just removed the inequality and we write the remaining part. So as long as you see inequalities in your classes, just remove the inequalities and that will be the class boundary. Then class width, subtract this minus this, is that, this minus this, this minus this, this minus this, is that. Now the first 4 tables were closed classes. They had both lower class limit and upper class limit. Now what we are going to look at are what we call open classes. It either has only lower class limits or it only has upper class limits. Now table 5 only has upper class limits, and also table 6 only has upper class limits. So how do we deal with such? The first thing to do is to get the class width, to find out whether the class width is the same, is constant, is equal, or unequal. So how do we get the class width for when we are given only upper class limits? So when you are given only upper class limits, to get the class width, start from the very end or start from the bottom. So I'm going to start from this, by filling here, going upwards. So how do we get it? Get this value minus this and put it here. That will be 10. Then also this value minus this, put it here. Then also this value minus this, put it here. Okay, now we have got that. For this one, we don't have any class above which you can use to get this value. So how do we do that? You look at all the entries of the class widths. If all of them are the same, it implies that even this one has to be the same as before. So we are going to put 10 there. Hope you have got the concept. It has to be all the rest must be equal in class width for you to put the same value here. If it is not, we shall see it in this case for unequal class width. But let's first complete the one with equal class width. After this, the next is easier because, like I told you, as long as you see inequalities, For class boundaries, simply remove the inequalities. So let's first remove the inequalities and write the upper class boundaries. Okay, then the lower class boundaries, still you start from the bottom. So get this value, put it here. Get this value, put it here. Get this value, put it here. Okay, now for you to get what to put here, you have to first look at this class width. Now class width is 10, meaning that 30 minus class width, which is 10, gives you 20, and that's what you put there. And by that your class boundaries will be generated. The next is the class mark. Class mark, now since the class limits only have one part, they don't have the other part, so we shall use the class boundaries to get the class mark. So this plus this gives you that, this plus this gives you this, this plus this gives you that, this plus this gives you that. Okay, next we shall go to cumulative frequency. Get this one, put it here. This plus this gives you what to put here, this plus this gives you what to put here, this plus this gives you what to put there. Okay, so that is table 5. Now table 6, where the class widths are unequal. So still, as long as the class has only upper class limit, always start from the bottom. So you come and say this minus this and put it here, then this minus this and put it here, then this minus this and put it here. Okay, now if you look at this, these ones are unequal. What does that mean? It implies that there's no way you can easily get what to put here. So how shall we get what to put here? To get what to put at this point, we are going to first leave it and try filling the class boundaries. So let's first leave this one blank for now, and then first fill the class boundaries. After that we shall be able to get what to put here. So this works for unequal class widths. For equal class width, you just put the value which is the same as the ones before. But here you don't do that. Let's see how it is done. So you go to our class boundaries. Now class boundaries still shall start from the bottom, like I told you. As long as there are inequalities, remove these inequalities and those will be the class boundaries. Okay, but we only have upper class boundaries. What about lower class boundaries? So what we are going to do the same as before. Get this value, put it here. Get this value, put it here. Get this value, put it here. Okay, now here we can't use this class width because we don't know it to get what is here. So as long as these class widths are not equal, here it must start from 0. Hope you have got that. As long as the class widths are not equal, the very first lower class boundary will be 0. So let's put 0 there. Okay, now that I've got this class boundary, I can easily get this class width. So 30 minus 0 gives you 30. So that's what I'm going to put here. It's a little tricky, but you have to master the concept, because these are the tables, or these are the categories of classes you will encounter in a level. Okay, so now we shall go to class mark. Class mark, now we can't get them from class limit, so we shall use these class boundaries. Therefore this plus this over 2 gives you that, this plus this over 2, this plus this over 2, this plus this over 2. Okay, the next is cumulative frequency. This, put it here, then this plus this gives you this, this plus this gives you that, this plus this gives you that, and that is your cumulative frequency column. So now we shall go to table 7, which is also opening classes with equal class width, but this time they have only given you the lower class limits. So how do you deal with such? Now when they give you upper class limits, you start from the bottom going upwards to get the class width. But when they give you lower class widths, when they give you lower class limits, you start from the top going downwards. So let's do that. Now how do you do it? You'll say this minus this, you put it here. Then this minus this, you put it here. Then this minus this, you put it here. Okay, now this one you don't have anywhere any other class after this. So what we do, we'll look at the ones we have written. Are they all the same? If they are all the same, then this one will be given a value which is similar to them. So you put there 10. Then from there we shall go to class boundaries. So class boundaries, now here also we start from the top going downwards. So this one, put it, okay. Let's first write all these ones here. Then from there, get this value, put it here. Then get this value, put it here. Get this value, put it here. Okay. Now from there we shall look at this one. Previously we said upper class boundary minus class width, but now since we have lower class boundary, we shall say lower class boundary plus the class limit. So class width to give you 90, which we shall put here. Okay, now we shall go to class mark. Class mark, now we shall get them from class boundaries. So this plus this gives you that, this plus this gives you, this plus this gives you, this plus this gives you that. Then now we shall go to class, cumulative frequency. So get this one, put it here. Then this plus this gives you that, this plus this gives you that, this plus this gives you that. Okay, so now we shall go to the last table, which is table 8, open classes with unequal class width. So just like we did, we are going to start from the top going downwards. So this minus this, put it here. Then this minus this, put it here. Then this minus this, put it here. Okay, so now these ones are unequal and we don't have any other class here. So what we do, there is no way we can get this end value. So what we do, we are going to put a dash. So we shall come and put a dash. So for lower class limits, just put a dash, because there is no way you can get this last value. Now that I've put a dash, we are going ahead and put our class boundaries. So class boundaries, first we are going to first write these ones still. So let's do that. Then from there, get this one, put it here. Get this, put it here. Get this, put it here. Okay, now here you don't have any value which you can add to this to get the upper class boundary. So what we do, we also leave it blank. Then we shall go to the class mark. Class mark, this plus this over 2 gives you this. This plus this over 2 gives you this. This plus this over 2 gives you that. Now here we don't have any value to add to this 85. So what we do, we also put a dash, because there's no way you can get it. Then we shall go to cumulative frequency. This, put it here. Then this plus this, put it here. Then this plus this, put it here. Then this plus this, put it here. So those are the tables you will encounter in your A level, and you must be conversant with them. So now that we have seen the various categories of classes under grouped data, now we shall go to parameters of grouped data. Now these parameters are like the parameters which we got for frequency distribution of ungrouped data, but the formulas or the formulae will differ. So for example, the formula for getting mean will differ, variance will differ, standard deviation will differ, like that, as we shall see below. So for example, mean, this is the formula. It is somehow the same as the one we saw before, but the difference is that now the x means class mark. Previously x meant data value, but now x means class mark as long as it is grouped data. Frequency is the same. F is frequency, fx is summation of fx, like that. So the rest is the same, but this x has changed. Okay, sometimes they can give you an assumed mean. If the a is the assumed mean, it implies the deviation d will be got by x minus a, and therefore your mean will be now a plus summation of fd over summation of f. It is now no longer a summation of fx, it is now fd. Then variance, still the formulas are the same, but like I told you, what is changing is the x, because for grouped data, x means class mark. Now if they give you the assumed mean, then variance will be in this form. It's no longer x here, it is now d. And those formulae are also available in your mathematical tables. Then standard deviation is square root of variance. So next is median. So this is the formula for median, and the good thing, the formula is also available in your mathematical logbook. So let's first look at the one in your mathematical logbook. So in your mathematical logbook, this is the formula. So there's something we need to change in your mathematical logbook. Here they said lower limit, which is not okay. So this word limit has to be boundary, because we use lower class boundary. Then small n is the total frequency, small c is the cumulative frequency, and I is the class width. So I think you see that their letters are a little different from ours, because in our case, C, we have said that C will always denote class width, but for them they are using I. Then we said class cumulative frequency will be denoted by capital C, capital F. For them they are using small c. Then total frequency, we said it will be denoted by capital N. For them they are using small n. And lower class boundary is LM. For them they are just using L. So the difference is just in the letters we are going to use, but the meaning will be the same. So let's stick to these letters because they are the very letters we used in our O level. So let's stick to them. LM to denote the lower class boundary of the median class. Then capital N to denote the total frequency. Then a half n, the whole of this half n would denote the median position. Then CFB to denote cumulative frequency before the median class. FM to denote frequency of the median class. Then small c to denote class width of the median class. Okay, now we have talked about median class. How do we get the median class? So to get the median class, the median class first of all is the class which corresponds to a value slightly greater than or equal to a half n in the cumulative frequency column. So remember, under grouped data, here we are getting median position, but now we are getting median class. This is median class. So this position helps you to get the median class. Then after that you use this formula to get the actual median that you want. The next is lower quartile. So what is changing? The formula for median is the same formula for quartile or decile or percentile, but what changes is this, the position, for example, but the rest is the same. For example, here it was lower class boundary of the median class, now it is lower class boundary of the quartile class, lower quartile class. Here it was cumulative frequency before the median class, now it is cumulative frequency before the lower quartile class. This was frequency of the median class, now it is frequency of the lower quartile class. And this was class width of the median class, now it is class width of the lower quartile class. So the formula remains the same, but what changes is this position. So that's what you should remember. So quartiles, deciles, percentiles, they get their formula from the median. So what changes will be the position. Okay, so even here upper quartile, the position is what changes. It will be 3/4n, but the rest will be the same. So for example, L23 denotes lower class boundary of the upper quartile class. CFB denotes cumulative frequency before the upper quartile class. F23 denotes frequency of the upper quartile class. C denotes class width of the upper quartile class, like that. That is quartiles. What about deciles? Decile is the same. Kth decile means that this position will change, but the formula will be derived from the formula for median. Therefore, LK will denote be the lower class boundary of the kth decile class. This one is the position, kth decile position. Then this one, cumulative frequency before the kth decile class. This is frequency of the kth decile class, and it's the class width of the kth decile class, like that. What about percentiles? Percentiles still, they get their formula from median. What changes is this position. So always remember median, percentiles, percentiles, deciles, and median, quartiles, percentiles, and deciles, they all have the same formula, but what changes is the position. So with that, we are going to use this question 1 still to go through these questions. So question 1 says the table below shows the amount of current I at which the electric fuses blow when it passes through them. So it's the current and this is the number of fuses. Calculate Roman 1 the mean, variance, standard deviation of the current, limits within which the standard deviations of the mean current, within 2 standard deviations of the mean current. That is just English, but it's doable. So then next, median, 80th percentile, 4th decile. So let's see how these ones can be got. So the first thing to do, like we did for frequency distribution for ungrouped data, even here we have to first tabulate the values which will help us to answer the questions that follow. So the first column will be the class, but now here in O-level we used to write here the word class. Now we don't need to write class. What we have to write is what is given. If nothing is given, then we can write there the word class, but in this case we are given here current, so that is why we are writing here the word current. Okay, that is 1. Then 2, we said these ones, when they are inequalities, it implies that the class limits are the same as the class boundaries. So what does that mean? It means that drawing 2 columns, one for class limit, another for class boundary, will be repetition. So what we do, we only combine the 2 into 1 column, and that will be the column of class boundary, because that's what we are going to use to answer the questions. So what we are going to put here, we are going to put class boundaries. So let's do that. And like I said, class boundaries are put by ignoring the inequality sign. Okay, the next is frequency. Now frequency are these number of fuses, so we're going to write these very values under the column of frequency. Then we have to get the total, which is 125. Okay, so now that you have those 2 columns, you can generate the rest of the columns. Let's start with X, which is the class mark. Class mark is got by getting this plus this over 2 to give you that. This plus this over 2 gives that. Then this plus this over 2. 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 And that's our column for X. Next will be the column for fx, so we have to multiply this times this gives you, this times this gives you, this times this gives you, this times this, 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 this times this. Okay, now next we have to add all these ones and get the total, which will be this. Now because they also have some variance, we have to get fx squared. So fx squared, it will be this times this squared to give you this times this squared, this times this squared, this times this squared, this times this squared, this times this squared. Sorry, this time it is supposed to be this times this squared. Okay, then this times this squared, this times this squared, this times this squared. Okay, then also we have to add all these values to come up with this total. The next is cumulative frequency. Because there was percentile and decile, so we have to get cumulative frequency. So get this value, put it here, then this plus this gives you what is here, then this plus this gives you what is here, 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 and this plus this gives you what is here. Okay, I think we realize that this total frequency is the same as this last value in CF column. The next will be class width. So class width, we get it from class boundary. So this minus this gives you 3, this minus this gives you 1, 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 this minus this gives you 5. Okay, so we have generated our table and we can now go ahead to answer the questions. So the first question was mean, then 2 variance and standard deviation. Let's first see those 3. So for mean, summation of fx is 3861.5 and summation of f is 125. That's what we are going to use. So you come here and say that mean is f summation of fx over summation of f. So summation of fx is this, summation of f is this. Use the calculator, we'll come up with this value. Then for variance, we need summation of fx squared, and that value will be this total here. So that's what you're going to write. So you come here and quote the formula, then substitute this, put this here, substitute for this, substitute for this, substitute for this. In the end you come up with this as the answer. It is okay to round off to 4 decimal places here. The next standard deviation, you get the square root of variance, which is that. Now next, Roman 4 had some English there. Let's see how it was. Here they said limits within 2 standard deviations of the mean current. What does that mean? It means that first you have to know there was the value of mean, and also they talked about mean, and also they talked about standard deviation. But for standard deviation they said 2 standard deviation. Therefore the limit will be mean plus or minus 2 times standard deviation. So when you substitute for mean and standard deviation, you come up with this. Therefore the limit will be, lower limit will be this when you use minus, and upper limit will be this when you use plus. Then Roman 5. So for Roman 5, Roman 5, they said calculate the median. So median, the first thing to do is to get the median class. So let's first get the median class. So median class or median position is a half n, which is 62.5. So that means that we shall go to our CF column and look for 62.5. So 62.5 lies here because 62.5 is bigger than 45. That means that is enclosed in 75. So this is what we call the median class, and to help us so much to get our value of median. So remember, the formula requires the lower class boundary of the median class, and that will be 30, because remember this one is a column for class boundary. Then 2 requires frequency of the median class, and to be 30. Then it also requires cumulative frequency before the median class, and to be 45. Then it requires class width of the median class, and it will be 1. So those are the ones they want. Let's go and substitute them in the formula. So come and substitute for lower class boundary of the median class, then position, which was already got, then cumulative frequency before the median class, and frequency of the median class, and the class width. In the end, you come up with this as your median. That was Roman 5. What about Roman 6? Roman 6, they wanted the 80th percentile. So that means that we have to first get the position. So the P80 position will be 8 over 100 times n, which is n was 125, and to be 100. So we shall look for that 100 in the CF column. So let's first remove this and locate our 100 in the CF column. So 100 lies here because before this there is 93, which is smaller than 100. Therefore this is the median class, and like we did in this is the 80th percentile class, and like we did under median, we have to get the lower class boundary, which is this, then we get the frequency, which is 14, then we get the cumulative frequency before that class, which is 93, and also the class width, which is 1. Once we have that, we shall go and substitute in the formula. So let's substitute. So lower class boundary, it was this, then the cumulative frequency before the median class, frequency of the median class, and class width, and that gives you 32.5. Okay, so now we shall go to Roman 7. Roman 7, they wanted the 4th decile. So first of all, you have to first get the 4th decile position, which is 50. Therefore, we shall go back to our column, cumulative frequency column, and locate where that 50 lies. So that 50 lies in 75, because before 75 it is 45, which is smaller. Therefore, the lower class boundary is 30, frequency is 30, cumulative frequency before that class is 45, and class width is 1. So when you substitute that in the formula, we shall be able to get our 4th decile. So let's do that. So substitute for lower class boundary. This is the position which was got here. Cumulative frequency before the median, before the 4th decile class, frequency of that class, and class width of that class. So when you use the calculator, you'll come up with this. So that was question 1. Then we shall go to question 2, which says the table below shows the distribution of masses of 80 potatoes in a research station in grams, mass and frequency. Okay. Calculate Roman 1, the median Roman 2, semi-interquartile range Roman 3, decile range Roman 4, percentile range. So just like we said, we have to first tabulate our values. So we shall start with the mass, and for mass we shall put there these ones. Like I said, these ones are the same as class boundaries as long as they are inequalities. Therefore, we are going to just remove the inequalities and combine the class limits with the class boundaries, and that will give us this. The next is frequency. Frequency is the number of, this is the frequency here, they put it here, so we shall write those values. So those will be the values for frequency. The next is cumulative frequency. So cumulative frequency, we keep on adding, therefore we shall come and say get this, put it here, then this plus this gives that this plus this, 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 like that. Okay, so now that we have finished generating our table, we can go and answer the questions. First they wanted median, then semi-interquartile range, then decile and percentile. So let's start with our median. So median, first of all, you have to first get the median position. So median position is 40. Therefore, we shall come and locate it in our cumulative frequency column. So when I locate 40, it will be inside 54, because before 54 there is 33, which is smaller. Therefore, I'll come and say that, okay, let's get the information. Lower class boundary is 50, frequency of the median class is 21, cumulative frequency before is 33, and the class width will be this minus this, which is 10. Class width is the same. Therefore, we shall come and substitute in the formula for median. So median position, put it here, lower class boundary, cumulative frequency before, frequency of that class, and class width. In the end, we'll come up with this value as the median. Then next they wanted the semi-interquartile range, so we have to first get the lower quartile. So the lower quartile position is 20. Now that I've got the position, I'll go back to my table and locate that position. So when I locate it, this will be the lower class boundary, frequency of that class, cumulative frequency before that class, and class width is the same, 10. So I'll come and code the formula and substitute lower class boundary, cumulative frequency before, frequency of that class, and class width. So in the end, we'll come up with this as the lower quartile. What about the upper quartile? So the position is 60. Therefore, I come and locate my 60. Okay, so this is the lower class boundary, frequency of that class, cumulative frequency before, and class width is 10. Therefore, we shall come and substitute those values in the formula. So when you substitute, you come up with 64 as the upper quartile. Therefore, semi-interquartile range will be interquartile range over 2, which gives you this. Then now shall go to Roman 3. So Roman 3, they want a decile range, so the first decile position is 8. So I'll come and locate 8 in my CF column. So 8 will lie here because 7 is smaller than 8. Therefore, that means that lower class boundary is 30, frequency of that class is 9, cumulative frequency before is 7, and class width is 10. Therefore, we shall come and substitute for those values in our formula. So code the formula and substitute. And the value, this will be the value of D1. Then we also have to get D9. So D9 position is 72. So come and locate your 72 in your table. 72 is here, meaning that the lower class boundary is 70. Frequency of that class is 7. Cumulative frequency before is 69. And class width is 10. Therefore, come and code the formula and substitute. So this will be your D9. Next is to get the decile range, which is got by subtracting to give you this as the decile range. The next was percentile range, so we have to get the P1 position, which is 0.8. So locate it. That will be the one. Then here, this is the lower class boundary, frequency of that class. Now cumulative frequency before this is 0, and the class width is 10. Therefore, you come and substitute and come up with 14 as our P1. What about P99? The position is 79.2. So come and locate your 79.2. Which is that. Therefore, lower class boundary is 80, frequency of that class is 4, cumulative frequency before is 76, and class width is 10. So we shall substitute those in our formula. And that would be the P99. Therefore, the range will be got by subtracting the 2 to give you this as the answer. Then question 3 says the weights in kilograms of 25 boys were as follows. So these are the weights and these are the frequency. Then calculate Roman 1 mean weight, Roman 2 variance, standard deviation, limits within 3 standard deviations of the mean weight. I believe by now this English should not be hard for you. Then Roman 4 number of boys weighing between 26.5 kilograms and 32.5 kilograms. So the first thing to do is to tabulate our values. So we shall need weight, which contains those classes. Then we shall need the frequency. Okay. Then we shall need the class mark. So I believe by now you know how to generate those class marks. So this is 22, 27, 30, 32.5, and 42. The next is fx. I believe by now you know, so this will be 66, 135, 60, 195, and 378. Total is 834. Then fx squared, this will be 1452, 3645, 1800, 63, 37.5, 15876, and the total is that. Then cumulative frequency, we have 3, 8, 10, 6, 25, which is similar to this. So now next will be class boundaries. So class boundaries, we shall have this, then this, then that, then this, this. The next will be the class width. We shall have 5, 5, 1, 4, 15. So I believe by now you know how to get all these parameters, the x, fx, fx squared, cf, class boundaries, and c. So now that we have tabulated, we can go ahead and answer the questions. So Roman 1, they wanted the mean weight. So mean weight, we need the summation of fx and the summation of f. So you come here and write the formula for mean, substitute, and get the value. So that was Roman 1. Then Roman 2, they want variance. So for variance, we need this total for fx squared. Quote the formula, substitute, and get the output, and that will be the variance. Then Roman 3, they want a standard deviation. So standard deviation is the square root of variance, so to be given by that. Then Roman 4, the limits within 3 standard deviations of the mean weight. So shall code the formula, substitute, and then get the lower limit and upper limit, and that's what they wanted. Then for Roman 5, they said the number of boys weighing between 265 kilograms and 32.5 kilograms. Now those ones, remember, the classes or the class boundaries are the ones which denote the weight. So they have given you the weight and they want you to get the value from here. So that means that we need a column for cumulative frequency. Remember, cumulative frequency denotes total frequency up to that point. So for example, 26.5 is somewhere in between here, so the value is between this and this. Then 32.5 is somewhere in between here, so the value is between this and this. Therefore for n1 we are going to get them separately. Now for n1 the value is between those two values, so we are going to compare this with the upper class boundaries. So what we need is this and this upper class boundary, this and this upper class boundary. We are going to extract out those two and see how we can use them to get the value of n1. So we have not yet defined our n1, so let's go and define it. So let n1 be the number of boys below this, or number of boys weighing this and below. So this one was supposed to be weighing this and below, and n2 be the number of boys weighing, so this was supposed to be weighing this and below. So we shall draw cumulative frequency and upper class boundary. So for 3 upper class boundary is this, then for n1 is we have this as to act as the upper class boundary, Then for the other part 8, the upper class boundary is this. What about N2? So N2, when you go back to the table, N2 is in between those ones because 32.5 is between 31 and this, meaning that is somewhere in between here. Therefore, we shall extract out those cumulative frequency and upper class boundary. So let's do that. So 10 corresponds to this, then N2 corresponds to 32.5, and 16 corresponds to that. Okay, now the question is, how do we get this N1? We have these 3 points, they lie on the same line or on the same OGIVE. So what we shall do, we shall take this one as a straight line and say it has a constant gradient. Therefore, change in y over change in x is the same. For example, here change in these two is n1 minus 3 over change in this and this, which is this, is the same as change in these two, which is this, over change in this and this, which is here. Therefore, next is substitute, simplify, and make n the subject, n1 the subject. Now we shall do the same for n2 and make n2 the subject. Now that I've got the 2, I can get the required number of boys because they're in between those two. So it will be 13 minus 5 to give you 8 boys. So now we have been dealing with calculations. Now we shall go to what we call an OGIVE. So an OGIVE, or cumulative frequency curve, is a curve that results from plotting cumulative frequency against upper class boundaries. Note this word, upper class boundaries, and then connecting the consecutive points using a smooth curve. And this OGIVE is used to determine median, quartiles, deciles, and percentiles. So far we have seen how to get these ones using the calculation method, but sometimes they can tell you to draw an OGIVE and estimate these very values. So that's what we are going to look at under this part of OGIVE. So there's nothing to write more. Let's go straight to the question, because you already know that an OGIVE, you draw cumulative frequency against upper class boundaries, and that is all you need to know. The next thing you need to know is that you join the points using a smooth curve, and we have already talked about it in the introduction. So now let's go straight to the questions. So question 1 says the table gives the frequency distribution of heights of 400 children in a certain school. These are the heights and these are the frequencies. Draw a cumulative frequency curve for the above data and hence estimate the median, interquartile range, and the 10th to 90th percentile range. Okay, so when you see these inequalities, I believe by now you know how to deal with this, because this is an open class with only upper class limits. So the first thing to do is to tabulate the values. So height, we shall put there the class boundaries, because the class boundaries is the same as the class limits in this case. The next is the frequency. And next is the cumulative frequency. So this will be 27, this plus this gives you this plus this gives you, plus this gives you, plus this gives you, plus this gives you, plus this gives you that. So for OGIVE we only need this and this, the upper class limits, upper class boundaries. So once you have them, you need the graph paper, and after the graph paper you put the horizontal axis and also the vertical axis. Then put a scale for the horizontal axis. So then you also put a scale for the vertical axis and label it. Okay, now here what I think you realized, in your O-level you used to put here cumulative frequency and you used to put here upper class boundary, but now we no longer need that. What we need are these very parameters given. For the classes they gave you height, so that's what you put here. Then for the frequency they gave you number of children, so that's what you put here. You don't need cumulative frequency anymore. So that's what you put here, but as you're plotting, you must remember that you're plotting upper class boundary with cumulative frequency. So let's do that. For example, the first point of 1110 corresponds to 27. So you shall come and for 1110 put 27 there. Then 120 corresponds to 85. So 120 will correspond to 85. 130 corresponds to 215, which is there. Then 140 corresponds to 320, which is here. Then 150 corresponds to 370, which is here. Then 160 corresponds to 395, which is here. And lastly 170 corresponds to 400, which is here. Now after that we are going to draw a smooth curve through all these points. Okay, but I think realize that we started from the lower class boundary of the first class, so you have to elongate this line to meet this at 0, to meet the lower class boundary of the first class at 0, so that we don't leave your OGIVE hanging. Therefore let's draw a smooth curve through those points. It must be as smooth as possible. Okay, now we have drawn, and next is to use it to answer the questions. Now for Roman, okay, let's see the question. Roman 1, they wanted median. So median, like we did in calculation, you have to first get the position. So we shall go and calculate our median position. So median position is 200. So what does that mean? It means that you'll come here and locate your 200 on the vertical axis and draw a horizontal line to meet the curve. So let's do that. It should be dotted. Okay, so it has made the curve at this point, so we are going to drop a perpendicular to meet the horizontal axis. So let's do that. Okay, then after that we are going to read off this point on the horizontal axis, and that value will be 129. Therefore you'll come here and say that the median is 129. Okay, that was Roman 1. Then Roman 2. Roman 2, they want the interquartile range, so you have to get the upper quartile and lower quartile, but for you to get them you need to get their positions. So let's first get the position of both the upper and lower quartile. So the lower quartile position is 100. Therefore we shall go back to our graph or OGIVE and locate 100 on the vertical axis. Then draw a horizontal line to meet the curve. Let's do that. Then drop a perpendicular from this point where the line meets the curve to meet the horizontal axis. Then read off this point, and that will be your lower quartile. So shall come here and write our lower quartile. Then next we also need the upper quartile. So upper quartile position is 300. So shall come here and do the same, locate 300, draw a horizontal line to meet the curve. It meets at this point, so draw a perpendicular from that point to meet the horizontal axis and read off this value, and that value will be 137.5. so that will be your upper quartile. Therefore we shall come and say upper quartile is 137.5. Therefore the interquartile range will be the difference between the two, which is 16. Then now shall go to Roman 3. So Roman 3 wants 10th to 90th percentile range, so we have to get P10 and also P90 using the OGIVE. So we need to first get the position. So P10 or 10th percentile position is 40, therefore we shall come here, locate 40 here, and take a horizontal line to meet the curve. Then drop perpendicular to meet the horizontal axis and read off this point, and that value will be 112, which will be your P10 or 10th percentile. So shall come here and write that our 10th percentile is 112. What about 90th percentile position? It is 360, so shall come here and locate 360 on our vertical axis. Take horizontal line to meet the curve, drop perpendicular to meet the horizontal axis, and read off this value. It will be 147.5. Therefore, you'll come here and say that my 90th percentile is 147.5. Therefore, 10th to 90th percentile range is the difference between the two, and to be 35.5 centimeters. That was question 1. Now we shall go to question 2. Question 2 says, the marks scored by 160 students in a test marked out of 100 were recorded as shown below. So these are the marks and these are the number of students. Draw a cumulative frequency curve and use it to find the range of the middle 60%. Now here there is also some English. Then Roman 2, the range of the middle 20%. But if you are keen with it, you realize that this is percentile because of this word percent. But the question is, which range of the percentile do they want? Let's see that. So like we have always done, the first thing to do is to tabulate the values of interest. So we shall start with the class boundaries. Then go to the frequency, and lastly cumulative frequency. So this is that, this plus this is that, 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 this is that, plus this is that. Okay, now next is to draw. So you need a graph paper. Then draw the horizontal axis and vertical axis. Then put a scale on your horizontal axis and label it. Do the same for the vertical axis and label it. Okay, the next is to plot. So plotting 10 corresponds to 2, so shall put 2 here on 10. Then 20 corresponds to 9, so shall put 9 here. Then 30 corresponds to 30, so shall put 30 there. 40 corresponds to 55, so shall put 55 there. 50 corresponds to 85, so shall put 85 there. 60 corresponds to 120, so shall put 120 there. 70 corresponds to 148, so shall put 148 there. And lastly 80 corresponds to 160, so shall put 160 there. The next is to draw a smooth curve through all these points. But remember, we must not leave your OGIVE hanging, so it should join the lower class boundaries, so up to his point. So let's do that. Okay, so after that, next is to answer the questions that follow. One, they said the range of the middle 60% of the distribution. Now middle 60%, which percentile is that? So let's do some little calculation here to identify which percentile they want. We shall make a sketch here. That percentile starts from 0, P0 up to P100. Therefore, let this one be the midpoint, and midpoint will be P50. Therefore, middle 60%, it means that from here you stretch 30 this side and also 30 this side. So let's put those 30s there. Okay, that means that this remaining part will be 50 minus 30, which is 20. Therefore, this is P20. And this remaining part will be 50 minus 30, which is 20, meaning this will be P80. Therefore, the range they want is from 20 to P20 to P80. So we have to get P20 and P80, then we subtract the 2. That will be the range of the middle 60%. So let's first get the P20 position. It is 32. Therefore, we shall go on our graph and locate 32 on the vertical axis. To meet the curve here, then draw a perpendicular to meet the curve at this point, to meet the horizontal axis at that point. Then read off that value, it will be 31, and that will be your P20. Therefore, we shall come here and say P20 is 31. What about P80? So we first get the position, which is 128. Therefore, you come back to your graph and you locate one, draw a horizontal line from 128 to meet the curve, then draw perpendicular to meet the horizontal axis and read off that value. It will be 62. Therefore, your P80 is 62. So you come here and say P80 is 62, therefore the middle 60% is this minus this, which is 31. Okay, that was middle 60%. What about middle 20%? So middle 20%, still we shall do the same sketch. Then put the midpoint, then middle 20 is here, meaning that this 20 is split 10 this side, 10 this side. So let's do that, 10 that side, and also 10% that side, meaning this remainder is 50 minus 10, which is 40, and also here it is 50 minus 10, which is 40. Therefore, this is P40 and this is P60. Therefore, we need to get the 40th percentile position, which is 64. So we shall come and locate 64 and draw a horizontal line to meet this curve, draw perpendicular to meet the horizontal axis, and read off that value, which is 42.5. Therefore, you come here and say that P40 is that. What about 68th percentile position? To be 96, so come and locate your 96. Then draw perpendicular from that point and read off this value. To be 53, therefore shall come here and say that P60 is 53, and the range is the difference between the two, and that's what they wanted. So that was question 2. Now shall go to question 3. Question 3 says the table below shows the cumulative marks scored in paper 1 of the mathematics contest by 100 students in a certain school, as shown here. Draw a cumulative frequency curve and use it to estimate median mark, decile range, number of students that would not qualify for paper 2 if the pass mark is fixed at 45%. Okay, then Roman 4, the least mark if the top 20% of the students are to be awarded. So these last two Romans need some little English, but we shall see how to do them. So let's start with, for median, okay, let's start with our OGIVE. So for OGIVE we need to tabulate some values, so let's do that. So we shall start with the class boundaries. Then the good thing in the question, they gave us cumulative frequencies, so we shall put them there, and those are the only columns we need to draw our OGIVE. So we shall get a graph paper, then draw the horizontal axis and also the vertical axis. After that we shall put a scale for the horizontal axis. Then we shall also do the same for the vertical axis. Okay, then we shall start plotting. So 10 corresponds to 5, so we shall put 5 there. Then 20 corresponds to 9, so we shall put 9 there. 30 corresponds to 16, so we shall put 16 there. 40 corresponds to 26, so we shall put 26 there. 50 corresponds to 41, so we shall put 41 there. 60 corresponds to 60, so we shall put 60 there. 70 corresponds to 77, so we shall put 77 there. 80 corresponds to 90, so we shall put 90 there. 90 corresponds to 98, so we shall put 98 there. And 100 corresponds to 100, so we shall put 100 there. The next is to draw a smooth curve through all these points. So let's do that. Okay, so now we can go ahead and answer the questions that were asked. Let's start with Roman 1. Roman 1, they wanted the median mark. So median means you have to first get the median position. So median position is 50, so go back to your graph and draw a horizontal line through 50 to meet this curve, draw perpendicular to meet the horizontal axis, and read off that value. 55 will be now your median. So just come here and conclude that the median is 55. Then Roman 2, they want the decile range of the marks scored. So we need D1 and also D9. Let's first get the position. So D1 position is 10. Therefore, you'll come here and locate your 10 on the vertical axis. Take a horizontal line to meet the curve, then draw perpendicular to meet the horizontal axis and read of that value, which is 22. That is D9. D1. What about D9? So D9, the position is 90, so you'll come and locate your 90 on the vertical axis. Then take a horizontal to meet this point, then draw perpendicular to meet this point and read off that value. Then from there you'll come and subtract the 2 to get the decile range. Okay, that was Roman 2. Now we shall go to Roman 3. Roman 3 said the number of students that would not qualify for paper 2 if the pass mark is fixed at 45%. Now remember, marks are these classes, so this 45 is under the class boundaries and the number of class students will be under the cumulative frequency. Therefore, what we are going to do, we shall come to our OGIVE, and under the class boundaries which share the marks, we shall locate our 45. Locate 45 here and take a vertical line to meet the curve. Then take horizontal line to meet the vertical axis, because this vertical axis is the one which has the number of students which they want. So what you're going to do, you're going to read this value, and that value will be 33. So these ones below will not qualify. Therefore, you'll come here and say the required number of students will be this, the ones who will not qualify. Then Roman 4. Roman 4, they said the least mark if the top 20% of the students are to be awarded. Top 20, it means that you have to first get the ones below. So the least mark position will be 100 minus 20 to give you 80%, because these are the ones which are below, and the position will be 80. Therefore, you go and look for your 80 on your OGIVE. Then take a horizontal line to meet the curve and drop a perpendicular to meet the horizontal axis. Then read off that value. It is 72. Therefore, you shall come here and say that the least mark is 72. Here, there was an S missing here, so you'll put it there. So that has been OGIVE. Now we shall go to what we call mode for group data with equal class width. Remember, we said in Alevel the class widths can either be equal or unequal. So in this case, we are dealing with equal class widths. So the formula is this, and it's also available in your mathematical logbooks. If you look at this, we have this formula. So for this, let's first look at this one, then we shall compare it with the one in the table. So this one, delta 1, okay, LM is the lower class boundary of the model class. We shall see what a model class is if you look at this note or this. Then delta 1 is the difference between the model frequency and the pre-model frequency. Now, pre-model is the frequency before the model class. Then delta 2 is the difference between the model frequency and the post-model frequency, so frequency just after the model frequency. C is the class width, we have already seen that. Then the model class is the class with the highest frequency. And the note is that for group data with equal class width, the mode can be got from the histogram of frequency against class boundaries. So there are two methods. You can either use this formula or use the histogram. It will depend on how the question is set. So let's look at the formula for the table, for the mathematical table. Now here they didn't put delta 1. Now delta 1 is this difference, model frequency, pre-model frequency. And here you see there is 2 F1, because one F1 will compare it with this, will combine with this to get your delta 1. Another F1 will combine with this to get your delta 2. So in the end you have D1 over delta 1 over delta 1 plus delta 2, which is similar to ours. Then I, like I told you, for them I is class width, but for us we are going to use C to maintain with C. Then L, like I told you, here it is an error, so it's not limit, it is boundary. So this is boundary. So you edit that in your table. So now that we have seen that formula, we can go and answer some questions. So we shall start with question 1, which says the table below shows the age in years of mothers at the time they had their first child. These are the ages and these are the number of mothers. Then they said calculate the model age of the mothers. So first of all, here these ones are the class boundaries, because when it's open class it means that the class limits are the same as class boundaries. Therefore, first of all, you look for the model class. Model class is the one with the highest frequency, and to be this. Then the lower class boundary of the model class is 30. Then the class width, this is equal class width, so it is this minus this, which is 5. Okay, that's why you see 5 here. Then next we have to get delta 1. So this minus this gives you this 14, and this minus this gives you this 10. Okay. The next is to substitute in the formula for mod and use a calculator to get this value, and that's what they wanted. Then question 2, Shalom recorded data on observation of time spent by Form 4 students of Ndege SS at the library as follows. So it's the table, and they said calculate the mod of the given data. So still we shall do the same, but here they have given you cumulative frequency instead of frequency, so you have to first calculate the frequency. And also they have given you class limits and not class boundaries. So we shall get cumulative frequency, write these ones here. The next is to get the frequency. So frequency, first write this one there, then this minus this, put it here, this minus this, put it here, this minus this, put it here, this minus this, put it here. That is now frequency. The next is class boundaries. So like I told you, first get this difference, divide by 2, and keep on subtracting from lower class limits and add to lower class boundaries. When you do that, we shall come up with these values of class boundaries. The next is to calculate lower class boundaries. So model class of this frequency, it is this 200, which is bigger, so this will be your model class. So the class lower class boundary is this, and then the class width is this minus this gives you 10. Then delta 1 will be this minus this to give you 100, and delta 2 will be this minus this to give you 100 or so. The next is to code the formula, then you substitute and get the output, and that will be the mod they wanted. Then question 3 says table below shows a frequency distribution of marks scored by 55 students in a test. So there's the table. Then it said draw a histogram of the data and use it to estimate the model mark. So histogram is frequency against class boundaries. So those are the class boundaries, and these are the frequencies. So we shall need a graph paper. Then we shall put the horizontal axis and also the vertical axis. Then put a horizontal a scale for the horizontal axis and label it. Do the same for the vertical axis. Then now we are going to start our plotting. So this class boundaries corresponds to 2, so we shall get 2 and put our bar there. The next is 6, so we shall locate our 6 and it is there. The next is 12, so we shall locate our 12, which is here. The next is 15, so we shall locate our 15, put it here. The next is 10, so we shall locate our 10. The next is 6, we shall locate our 6. Next is 3, we shall locate the 3. And lastly 1, we shall locate 1. So that is our histogram, but they said we want to use it to get the mod. So what we are going to do, we are going to use a ruler now, join this corner to this corner. Why? Because this is our highest frequency. So this is the model class, and the model should be in between this. So join this ruler from here to here to come up with that line. Then also the same, join from here up to here to come up with this line. Then this point of intersection, drop a perpendicular to meet the horizontal axis and read of that value. So that will be the mode they wanted. So it will come and conclude that mode is 44. So that has been mode for group data with equal class width. What if the class width are unequal? So the formula will remain the same, but how we use it will differ. For example, this is the lower class boundary of the model class, which is okay, but delta 1 is the difference between the model frequency density. Now we are adding there a new term, frequency density. Now what is frequency density? We shall see that in the next slide. Model frequency density and pre-model frequency density. So instead of using frequency, we use frequency density. That is the only difference, otherwise the formula is the same. Delta 2 also, frequency density is no longer now frequency. C is the class width of the model class, and the model class is the class with the highest frequency density. Now here it is no longer the class with the highest frequency, it is the class with the highest frequency density. Now the question is, what is frequency density? Now frequency density is frequency divided by the class width. And the note is that for group data with unequal class width, so this one, it should be unequal, not equal. With unequal class width, the mode can be got from a histogram of frequency density against class boundaries. It is no longer frequency, it is frequency density. So we shall see that in the worked examples. So let's start with this question. Question 1 says, calculate the model score for the data given in the table below. So the first thing to do is to realize that this width are not the same, because this from here to here, this minus this is 4, this minus this is 2. When you realize that, just know that it is unequal class width. Okay, so how do you deal with it? Draw, tabulate your values, put your class as scores, then put the frequency. Then from there we need C. So C is the class width. Now the good thing with this is that you realize this, they are the same values. What does that mean? It means that the class limits are the same as the class boundaries, so we don't need any other column for class boundaries. Therefore C should be got by subtracting. This gives you that, subtract this gives you 2, this gives you 6, this gives you 10, this gives you 8, this gives you 6. Okay, now that we have frequency and class width, we can get frequency density by dividing the 2. So this divided by this gives you 2, this divided by this gives you 5, this divided by this gives you 2, this divided by this gives you 1.5, this divided by this gives you 1.125, and this divided by this gives you 0.5. Okay, so now that we have our frequency density and class boundaries, we can calculate. So the first thing to do is to identify the model class. Remember, for unequal class width, the model class is got from frequency density, and in this case the highest is 5. Therefore delta 1 is this 5 minus 2 to give you this, and delta 2 is this 5 minus this 2 to give you this. The next is to code the formula and then substitute, and this will be your mode. Then question 2 says the table below shows the age distribution of workers in a certain school. Calculate the model age of the workers. So now here they are going to use the age and frequency density. So we have first put our classes. Now these are class limits. Then we have frequency density. Okay, but we don't have frequency class boundaries, so we shall put our class boundaries. I believe by now you know how to get the class boundaries. So those are the class boundaries. Now next is to calculate. The first thing to do is to identify the model class. So here the model, this is the highest. So delta 1 will be this minus this, which is that, and delta 2 will be this minus this, which is this. Okay, the next is to code the formula and substitute to get the model age they wanted. Then question 3 says study the table below. Then construct a histogram and using the above data, and hence use it to estimate the mode. So the good thing they've given us the frequency density, but we don't have the class boundaries and we need them. So let's first get the class boundaries. So those are the classes. Then this is the frequency density. What about the class boundaries? So class boundaries, we have to get them. We have those ones. I believe by now you know how to get them. Okay, now next is to draw our histogram. So we need a graph paper, draw the horizontal axis and also the vertical axis. Then put a scale for your horizontal axis. And do the same for the vertical axis. So next is to plot. The first one is 1.2, so come and draw your 1.2 there. The next is 1, so come and draw your 1 there. And you must be keen with the ranges. 1.2 starts from 19.5 to 24.5. 19.5, 24.5. Then this one starts from 24.5 to 34.5. 24.5 to 34.5. So you must be keen of the ranges. Then 1, 2 starts from 34.5 to 38.5. So draw it also. You must be keen of the ranges. So 1.5 starts from 38.5 to 44.5. So draw that. Then 1 starts from 44.5 to 49.5. So draw that. Then 0.4 starts from 49.5 to 54.5. So draw that. So that is our histogram, but they want you to get the mode, so you do the same. This is the highest, so draw a line from here to here, and also join from here up to here using a ruler, and then draw perpendicular from the point of intersection. After that, you read off this value. So that will be the mode, so you just come and conclude that the mode is 37. Then question 4 says the weights in kilograms of 25 boys were as follows. So the weights, display the data on a histogram and use it to estimate the mode. So we shall come and tabulate our values. Weights are those ones. So we are given also frequency. So you have to get the class boundaries. So those will be the class boundaries. Then next we have to get the frequency density, but for you to get it you need the class width. So class width will be, these will be the class widths. Then next, now you know how you have frequency, you have class width, so you can get frequency density. Okay. After that, then next will be now to draw a histogram. So you have extracted out the class boundaries and frequency density because that's what we need to draw the histogram. So you get the graph paper, draw the horizontal and vertical axis. Then put a scale for the horizontal axis. Do the same for the vertical axis. Okay, now next is to plot. 0.6 ranges from 19.5 to 24.5. Let's draw that. Then 1 ranges from 24.5 to 29.5. We shall draw that. Then 2 ranges from 29.5 to 30.5. We shall draw that. Then 1.5 ranges from 30.5 to 34.5. We shall draw that. Then 0.6 ranges from 34.5 to 49.5. We shall draw that. Okay, so that is our histogram. Next is to get the mode. So we shall get our ruler, join that point to this point, and also this point to this point, and draw perpendicular from the point of intersection, and read off that value. Now, reading of that value is a little tricky. How do we get this value? So first of all, this value is 29.5, so put it here. Then you count the number of small squares, 1, 2. That is why you see the 2 there. Then next, you have to get the scale for each small square. How do you do that? You count from here up to here. When you subtract, this is 34.5 minus 29.5, which is 5, which is this. And from here to here, how many small squares are there? They are, from here to here is 5, from here to here is 10 now, from here to here is now 15. That is why you see 15 there. So when you use a calculator, you'll be able to come up with the mode that you want. So that brings us to the end of this video. Thank you for watching, and bear in mind the next video will be on scatter graphs and correlation. So if you have not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video has been uploaded. And also, if you know of any student who's not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp, so that we can all benefit as a family.